The prevailing view among scientists is that current cosmological models, particularly the Big Bang Theory, remain the cornerstone for explaining the universe's origins. This foundational framework outlines a sequence through which stars and planetary systems emerged, eventually giving rise to life, including humans. Despite its unusual name, the Big Bang Theory presents a compelling narrative about the universe's earliest moments. All matter and energy were once compressed into an unimaginably tiny, ultra-dense point, far smaller than the head of a pin. From this singularity, a tremendous explosion of matter and energy occurred, setting the cosmos into perpetual expansion. However, as our understanding of astrophysics and cosmology deepens, the Big Bang model is facing growing scrutiny. The launch of the James Webb Space Telescope, JWST, the most sophisticated space-based observatory ever constructed, was expected to reinforce the Big Bang Theory. Yet, in a surprising twist, the telescope's first year of operation has yielded discoveries that are shaking the scientific status quo. With its extraordinary ability to peer into the distant reaches of space and time, the JWST has detected galaxies so ancient that they challenge long-held assumptions about the universe's birth. These findings have sparked intense debates, including questions about whether material might have existed even before the Big Bang, as we currently define it. One landmark moment came when cosmologist Rohinton analyzed JWST data and identified a galaxy that formed shortly after the Big Bang. It now holds a record as the most distant and oldest galaxy ever observed. This breakthrough has sent ripples through the scientific community, highlighting the revolutionary potential of the JWST's technology. The telescope is beginning to unlock fresh insights into the universe's formative epoch, a time known as the cosmic dawn, roughly 200 to 300 million years after the Big Bang, when the first stars and galaxies began to shine. These observations are already clashing with established models, revealing galaxies with characteristics previously thought impossible at such an early stage. This unexpected abundance of mature galaxies has energized the field, compelling scientists to urgently reassess their theoretical frameworks. As researchers probe deeper into JWST's findings, they are encountering profound questions about the fundamental nature of the cosmos and the forces that shaped its early development. Beyond its scientific breakthroughs, the JWST's strategic location, about 1.5 million kilometers from Earth, offers unique advantages. Positioned far from terrestrial interference and kept at near absolute zero temperatures by a tennis court-sized sunshield, the telescope is equipped with massive gold-coated mirror and ultra-sensitive instruments specifically designed to explore previously hidden corners of the universe. The discoveries emerging from this cosmic dawn period provide a rare opportunity for cosmologists to rigorously test, refine, or even overhaul their existing models. By studying the data from these ancient galaxies, scientists can evaluate the roles played by dark energy, dark matter, and the dynamics of gas and dust in star formation, ultimately pushing the boundaries of what we know about the origins of everything. The James Webb Space Telescope, JWST, was initially launched with modest expectations. Scientists anticipated it would detect only a limited number of faint galaxies from the early universe. However, those predictions were quickly outpaced. From its very first images, the JWST revealed a breathtaking abundance of galaxies, differing in age, size, and luminosity, far beyond what anyone had forecasted. This avalanche of early universe data has ignited a scientific race to redefine what counts as the universe's earliest massive galactic structures. These ongoing discoveries continue to astonish even the most experienced astronomers. As the JWST delivers more findings, both the scientific community and the public have been captivated by the complexity and maturity of these ancient galaxies. While some researchers suggest that certain anomalies may stem from misinterpretations or limitations in the telescope's large-scale observational methods, the broader consensus is that we are witnessing a genuine breakthrough, one that could fundamentally reshape our understanding of cosmic history. This emerging evidence paints a picture of the early universe as vastly more intricate than previously imagined. The findings raise profound questions about long-standing cosmological models. Some scientists believe these discoveries can be reconciled with current theories, while others argue they could be the first signs of a deeper, more mysterious universe. Central to the debate is one enduring question: how did the orderly cosmos we see today emerge from the chaos of the primordial universe? The JWST's early results may not only challenge core assumptions about the Big Bang, but also prompt new interpretations of distant galactic formations, some of which could even transform our understanding of the Milky Way itself. As Mark McFadden, a senior science leader at the European Space Agency, aptly put it, the purpose of building instruments like JWST isn't just to confirm what we already believe. It's to challenge those beliefs, sometimes even dismantle them. You never know what might get overturned. The idea behind JWST dates back to 1985, even before the launch of the Hubble Space Telescope. Then director of the Space Telescope Science Institute, Garway, was tasked with envisioning a next-generation observatory. Despite initial skepticism, he and his team laid the groundwork for what will become the JWST. Unlike Hubble, which primarily captured visible light, JWST was designed to observe in the infrared spectrum, a crucial feature. As the universe expands, light from distant galaxies is redshifted into infrared wavelengths, rendering it invisible to optical instruments like Hubble. JWST's massive, ultra-cold mirror allows it to detect these faint signals, effectively enabling astronomers to peer deeper into cosmic history than ever before. The need for such a telescope became undeniable in 1995 when Hubble's deep field image revealed a vast number of galaxies in what had appeared to be an empty patch of sky. This surprising glimpse into the crowded early universe underscored the urgency of building a telescope with far greater sensitivity. After decades of planning, development, and an investment of approximately $1 billion, JWST was finally launched on December 25, 2021. By July 2022, it was fully operational and began its groundbreaking mission. Programs like Early Release Science, ERS, and the General Observing Program were launched to search for the universe's earliest galaxies. Though early expectations were conservative, the telescope's initial data release shattered them. JWST's observations are now not only putting long-held cosmological theories to the test, they are beginning to overturn them entirely. The recent findings underscore the critical importance of pushing the boundaries of exploration and investing in state-of-the-art technology. With each new data release from the James Webb Space Telescope, JWST, scientists find themselves on the cusp of potentially rewriting much of what we thought we knew about the cosmos. When the telescope's first transmissions arrived, the scientific community was electrified. Years of preparation, analytical modeling, and anticipation culminated in the moment researchers could finally apply their tools to real observations. Rather than waiting for the often sluggish peer review process, many scientists opted to share their initial results through preprint platforms like AR-14. This approach enabled immediate access to cutting-edge findings and opened the door for rapid feedback and critique. The discussion quickly exploded across social media, particularly on platforms like Twitter, where experts debated and analyzed the results in near real time. Cosmologist Rohin Nada dubbed this phenomenon science by press release, reflecting the breakneck speed and heightened visibility of these scientific exchanges. While this openness accelerated collaboration and insight sharing, it also raised concerns among some in the scientific community. Klaus Pontoppidan, a lead JWST project scientist at the Space Telescope Science Institute, STSCI, warned that the rush to publish might compromise the rigorous standards traditionally upheld by peer review. The overwhelming stream of discoveries from a project of such magnitude has indeed strained conventional workflows. Nevertheless, the consensus remains. The challenges of rapid dissemination are a small price to pay for the profound breakthroughs being made. Currently, the Big Bang Theory continues to serve as a prevailing explanation for the origin of the universe. It describes how all matter and energy began in a single unimaginably dense point, smaller than a grain of sand, and expanded rapidly, giving rise to stars, planetary systems, and eventually life itself. Despite its somewhat misleading name, the Big Bang model offers a scientifically grounded framework for understanding how everything came into existence. Yet, as the JWST peers further into the depths of time and space, its observations are beginning to expose cracks in this long-standing model. The discovery of fully formed galaxies appearing much earlier than existing theories suggests that our understanding of the universe's timeline may be incomplete. These findings don't just challenge the Big Bang framework. They open entirely new avenues for exploring the fundamental forces that shape everything from subatomic particles to sprawling galactic clusters.